1.5, geometric properties of linear functions. The key points is we're going to talk about parallel and perpendicular lines, horizontal and vertical lines, and the intersection of two lines. Okay, well, let's talk about interpreting the parameters of linear functions. What do you remember most about the slopes of these three lines? Well, parallel lines, and in math we like to use this terminology. It looks like an 11, but that's parallel lines. Parallel lines have the same slope. They have to, or else they would cross somewhere. So, for example, you could have slopes of 5 and 5. Or you would have slopes of -3/2 and -3/2. If the slopes are exactly the same, the lines are parallel, they'll never cross. Okay? Perpendicular lines, the math symbol we use for this is perpendicular lines. They form a 90-degree angle. The slopes are negative reciprocal slopes. So an example with that would be -5 and -1/5. All right, excuse me, +1/5. You would have to actually flip it and change the sign. So it would be -5 and a +1/5. Or it would be -2/3 and a +3/2. That's negative reciprocal. So it's the opposite and you flip it. Horizontal lines look like this. Horizontal lines are usually y equals lines, and if you'll notice, the slope of these kind of are 0, because if slope is delta y over delta x, my x's are changing because I'm going from here to here, but my y's are not. So it's 0 over something, so the slope is 0. Vertical lines are always, they look like this, they're always x equals lines, and the slope is either undefined, we call it undefined, so let me erase that. Undefined sloped. Do not say 0. It's undefined or no slope. It's not a 0 slope. That's different. So if I had delta y over delta x, here you see my x's are changing. Excuse me, my y's are changing because I'm going up and down. My x's are 0 though. That's why it's undefined. Here my y's are 0. That's why that's the slope is 0. Here the 0's in the x's because the x's aren't changing but my y's are, so it's undefined or no slope. Okay, so we've got these three populations of which we talked about earlier. So first of all, we want to talk about which ones are linear functions, and let's see what they all stand for. So, and we're going to describe in words what each one tells us. So let's go through this first one. First of all, I look at it and say, all right, this is my beginning. So this town A starts at 20,000 people. So my beginning is my initial value. And we're going to do a thing of your slope or your growth. And when these are growing, and since it's people, the slope is really the number of people per year that's growing. So that's, when I say slope, that's your rate of change. So my initial value for this first one is this town started at 20,000 people, and it's growing 1,600 people per year. Oops, people, I forgot the L here. Okay, so it's people per year. This town started at 50,000 people, and what's happening this one? Oh, it's decreasing 300 people per year. So this town is getting smaller. This one we've got in a different order, but this one starts at 45,000 people. And it's growing 650 people per year. So these three right here are linear functions because it's a constant rate of change and it's going to be a straight line if we graph it. Now this one right here, we have multiplication, so this is not linear. In fact, this one is exponential, and we'll be talking about that next chapter. All right, so we just kind of went through. All right, so the three top ones are linear, and we went through. Now we want to know which town starts out with the most people. Well, the most people starts out, let's look, the most people starts out with this town, town B starts out with the most people, and then it says which town is growing the fastest, and we look, and the one that's growing the fastest is this one here for the linear. Truth be known, town D is growing the fastest because it's exponential, but we haven't learned that yet. But out of the linear ones, town A is growing the fastest. So here is just a page where I put everything together. You have your line y equals b plus mx, and you're graphing y against x, and all your points are x, y on your graph. The y-intercept b tells us where the line crosses the y-axis. You might also be known as calling your vertical intercept. So if you hear vertical intercept, it's the same as your y-intercept. It's always 0, a number. If the slope m is positive, the line climbs from left to right. If m is negative, the line falls from left to right. So this is a positive slope, and this is a negative slope. The slope m tells how fast the line is climbing or falling. So the larger the number, the steeper the slope. It's supposed to be the, guys. The steeper the slope. And the larger value m, either positive or negative, the steeper of the graph. Okay? Example number 2, it says, graph these three linear functions, show identifying the values of b and m, and then we're going to graph d and explain how the graph shows that it's not linear. So I actually graphed them for you. So let's see if we can identify which one's this one. So I see that this is town A because it starts at 20,000. Town B started at 50,000 and it was decreasing. And town C started at 45,000 and it's growing, right? Eventually all of those will cross because the slopes aren't the same. Now here is town D, and as you see it's curved, so this is an exponential function, and that's why it doesn't look linear, because your rate of change isn't constant. Now let's talk about horizontal and vertical lines. And again, what I told you, here's a horizontal line. This is crossing here. This is y equals 4, and the slope is 0. You could really write this as y equals 0x plus 4, because the slope is 0, but notice we don't write it that way. We write it like this. Then if I pick the line x equals 4, I couldn't graph it because, sorry, it's kind of wiggly, but this is the line x equals 4, and you can't write it in the other form because the slope is undefined. So your calculator actually will graph those now, but you have to put it in a different way. You have to actually call it a vertical line. So the graph of the equation y equals k is a horizontal line and its slope is 0. The graph of the equation x equals k is a vertical line and its slope is undefined. For the two lines, parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. So that's just a note page for you to have. All right, let's talk about two intersecting lines. I said find the point which these two lines intersect. Notice that the xy coordinates of such a point must satisfy the equations for both lines. So I have the line y equals 2x plus 1. So I'm just going to do a little sketch here so you can kind of see that they're going to are going to cross. So I have the line y equals 2x plus 1. So this is my b, this is my y-intercept, this is my slope. So I know it's going to cross at 1, and it's got a slope of 2. So we're just going to say it kind of looks like that. And I know it's in the positive direction. The other line crosses at 6. I'm doing a sketch. And the slope is a negative 3, so it's a little bit steeper. So it's going to kind of look like this. So where they cross right here is the intersection. And that point, xy, whatever it may be, will work on both lines. All right? So let's do the algebra. First thing you want to do is let's put them equal to each other. Since they both equal y, I can say, all right, 2x plus 1 equals negative 3x plus 6. And you're going to add 3x to both sides so that I can solve for x and subtract 1. So I have 5x equals 5, and then divide by 5, x equals 1. So now I know x is one of my xy point. So I'm going to plug in 1 and one of these equations, and it should work for both. So if I say y equals, I'll use the first equation, 2 times 1 plus 1, that's going to be 3. So now I know the y value is 3. And if you were to put 1 in here, you'd also get a 3. So now I know the intersection of the points is 1, 3. and that works on both lines. You can check it by looking at it. Now I actually graphed these here so you can see the 0.13 is really where it crosses. Okay, so I wanted you to see that. All right, let's talk about something in the real world, and this is the cost of renting a car for a day for 3 different rental agencies. Driving D miles, and C is the cost. All right, so I always tell you to label the crap out of it. So this is the cost of all of them, and it's usually in dollars. And D is in miles, even though it makes it sound like it's days, but it's miles. So let's describe in words what each one of these say. The first one says, all right, here's my cost. My initial cost is $50, and I get charged $0.1 per day. All right, and for driving D miles. So I'm like, okay. So if I get charged, not day, but excuse me, let me say that again. I charge 10 cents per mile. So these are all miles here. So this one is, we're going to write down initial cost of having that, and then how much it cost per mile. All right, so the very first one, my initial cost is $50, whether I drive anywhere, and then for mile, I get charged 10 cents per mile. This one here, my initial cost is $30, and I get charged 20 cents per mile. This one right here, there is no initial cost, but I get charged 50 cents per mile, or $0.50 per mile, which is 50 cents. So we've just kind of gone through these 3 rental agencies. So you have to realize which one is agency's the cheapest, because it all depends on how many miles you're going to drive, because this is how much I'm going to drive. And if you look at it, this one costs at most, but it's cheaper per mile. This one costs less amount, but it's 20 cents per mile. And this one doesn't cost anything, but it charges more per mile. So this question is hard to answer. So if I were going to take a short trip, like a small trip, the C3 would be cheaper because I would not drive as many miles, but I wouldn't have to put any money down. So C3 would be cheaper for a small trip because you don't have any initial cost. If I were to look at this one, the one for the longest trips, looks like C1 would be cheaper for longer trips because it's cheaper per mile. So I'm thinking C1 is cheaper for longer trips. So let's look at the graphs and see if we're right. And if you were to look at this, this is C3 right here where it has no initial cost. And this one starts out, this one was $50, so this was C1. The other one was $30, so this is C2. And if you look at it right here, they cross here at 100 miles. So it looks like, see how C3 is cheaper if you drive less than 100 miles. Okay? But if you kept using it and went on, see how C3 is really expensive? So for long trips, C3 is not good. All right? Now look at this one right here. C1 is the most expensive for a short trip, but if you keep going, so for longer trips, C1 is cheaper because it has a smaller slope, or the amount per mile. So this is for shorter trips right here. And that's for longer trips. Okay? Let's do a couple more examples. It says, write an equation of the line passing through this point, which is parallel. So this is what I want you to do. I actually split this up because it kind of confuses people. So I want to have it pass through the point. Here's x, y. And I want it to pass through that point, and they give you this equation. So here is my original line. So set this up. Here's my original line, and here's my new line. So they basically give you your original line, which is 2y equals 5x plus 3. And I want to come up with a new line, which is y equals b plus mx, but I have to find the b and the m of my new line, and then I'll have my new line here. But first you got to take the information from this one. So in order for me to figure out, because if I want to have it parallel, I know the slopes have to be the same, so let's divide this by 2 so we can see the slope of our original line. So if y equals 5 halves x plus 3 halves. Now I know this isn't in b plus mx form, but I can see that the slope is 5 halves, so I know that my slope here has to be 5 halves. So, okay, that's great. You don't need any other information. This 3 halves doesn't even help you. So that's all I need. And I know it goes through this point here, the point negative 4, 5. So here I go. So I write y equals b plus 5 halves x. And then plug in your x and y. So I have 5 equals b plus 5 halves times a negative 4. So that's 1, that's negative 2. So I have 5 equals b minus 10. Okay. So now I have to add 10 on both sides, so b is going to be 15. So my new line is y equals 15 plus 5 has x. And they're parallel because their slopes are the same. This one just crosses at 15. Okay. Write a line perpendicular. So here we go. We can do the same thing. Set it up. If I can draw here. Original line. New line. So again, I have the same original line. So let's just write it already solved because it's the same one we just did. Now my new line is going to be, I have to have an m and a b, and it's still through the same point, negative 4, 5. However, this one is perpendicular, so I know my slope of my new one is negative 2/5. So I say y equals negative 2/5 x plus b. Here's my x and y, plug it in. So I have 5 equals negative 2/5. My x is negative 4 plus b. I'm running out of room, so I'll go over here. I have 5 equals negative 2/5 times this, put it over 1, so that's going to be equals 8/5 plus b. And then, so b, I'm going to subtract 8/5 on both sides. And that's 25 over 5 minus 8, so that's 17/5 equals b. So my new line here is y equals 17/5 minus 2/5 x. And we're done.